Hello, everyone, and welcome to Token Engineering as a Public Good. This is a fireside chat format hosted by the Token Engineering Commons, featuring some of the top token engineering thought leaders in the space. The purpose of this chat is to discuss the importance of token engineering and its applications within our emerging digital economy, and how the proliferation of token engineering as a public good has the potential to transform how we think about, design, and build the sustainable and ethical token economies of the future. This discussion is part of our effort to highlight the token engineering grant round, where the Token Engineering Commons is providing a 25K matching pool to fund token engineering public goods. The application period is over, but we have 15 really awesome projects that the token engineering community can support. Donations are open today and will remain open on the Optimism chain until the 29th of August. So if you get an opportunity, please do take some time to learn about these projects and donate to the ones you believe might provide significant impact to this field. If you hold any TEC or possess any credential from the Token Engineering Academy, you will receive a matching boost for your donation. So please do consider it and let your donation make even more of an impact. With that being said, I want to take some time right now to introduce our panelists. We have 5 speakers on the stage now, and I was hoping that each of you could kind of introduce yourself to the community and provide a little context on who you are and how you got involved in the token engineering community. Let's start with you, Angela, and we can pass it around from there.
Yeah, hello everyone. I'm Angela, located in Berlin, founder of TE Academy and early member of TEC. TE Academy is providing education, the first comprehensive educational program actually in the sector of token engineering, since this is a new crypto native discipline combining computer science, cryptography, economics, game theory, drawing from other engineering disciplines, also from control theory, data science, AI, and human layer, behavioral science, decision science, governance, and ethics.
Yeah, thank you, Angela. And how about we pass it over to you, Livia? Would you like to introduce yourself and how you got involved in token engineering?
Thanks, Nate. Hi, everyone. I'm Livia. I work with Stack, and I'm an early contributor of the Token Engineering Commons. I was leading the cultural build of the TEC, so we were implementing Ostrom's 8 principles for governing the commons and the infrastructure of the TEC, and now I'm participating in a token engineering stakeholder study that we proposed to the TE community. We interviewed 41 participants to try to understand challenges, needs that TEs are facing, and what do we need for the discipline to advance. So we're in the phase of writing this report now that will be shared very soon. So I'm happy to be here and share more about it. And I can pass to you, Trent.
Sure. Hi, and great to be here, everyone. My background, I spent 20 years in the world of AI with a couple startups and a PhD, and since 2013, I've been in the world of blockchain. Since 2017, focusing on Ocean Protocol, which is, its goal is to help level the playing field around data and AI. Such that even independent researchers can have the same access to solve problems as someone in a large enterprise. And how I got into token engineering, all the way along, I'm a builder, I'm an engineer, I'm a huge nerd, so I like to build things and all that. And because I've been in crypto since forever, I was following a lot of the discussions, the nerdy academic discussions around incentive design, all of that. And really got into that deeply when we were designing Ocean in the early days. This was early 2017. And I just found that there was a collection of different ideas, proposals, and so on, but there really doesn't seem to be much of a community to discuss this or any label even around this. So I started writing about it. At first, I was calling it by other labels, and then from discussions with Zargum and others, it made sense that the label, token engineering would be a great label. And then working with Angela and others sort of kicked it off. I'd already been running meetups in Berlin for AI, for Singularity, for big chain DB, like blockchain stuff, like helping run myself. So I decided to just kick off a meetup around that, and Angela joined in, and basically that really took off there. And so I was there in the earlier days. I haven't spent as much time in the community the last couple of years, although I like to spend as much time as I can. Just my time is stretched very thin. So yeah, that's how I've been involved. And I generally like to contribute simply as a practitioner. My main day job, my main goal in general is to build and grow Ocean. But I see the importance of token engineering, I always have, and I try to report the learnings from a token engineering perspective as blog posts to the token engineering community, as talks, et cetera, too. So that's kind of, my background, how I got into it, and how I try to help drive the field forward. And build a tool here and there, too.
It's really awesome, yeah. How about you, YGT? Take to introduce yourself.
Hey, thanks, Nate. Thanks, everyone. Hi, Shawn Anderson here. I'm based on the west coast of Canada. I've got a background in computing science. I've got a master's degree from Simon Fraser University with a specialization in data science and machine learning. Been into crypto from a financial perspective since about 2012, and in 2018, I founded a firm called Longtail Financial with a focus on quantitative finance, algorithmic trading, essentially a consulting firm working in the algorithmic trading space. In about 2019, 2020, I started to get oriented with this term token engineering through reading the publications of Block Science primarily. That led me to finding the Token Engineering Academy and the Token Engineering Commons, going through some Academy courses, and then getting oriented with the larger space adjacent to Ocean Protocol and following Trent's work as well, and getting some direct mentorship from Trent as well. So in 2021, January, I pivoted the firm Longtail Financial to actually being a token engineering services firm. And since then, I've worked with my partner, Mike DeMello, on the call here, MD, the Llama, and we've served about 15 clients through Longtail across DeFi, NFT gaming, NFT pricing, marketplaces, and DAO construction primarily has been our sort of client focus. And I've also been working with the Token Engineering Commons since very early on in its creation, and I've been my role there was steward of the labs. I hosted sort of interactive development sessions, data science research and development sessions on a weekly basis for some time, maybe a year and a half. And I've just recently jumped back into the TEC with a very active role, focusing on the quadratic funding rounds that they're running. Like Nate mentioned, there's a live round right now. And the TEC is innovating this kind of SME signal injection, subject matter expert signal injection into quadratic funding. So right now, that's my primary focus, is working on that as a product, as a data scientist. Really happy to be here. Back to you, Nate.
Yeah, thank you. And we also have our final speaker, which is Octopus. If you welcome Octopus, if you'd like to introduce yourself and kind of get some context of how you got into the field of token engineering in the first place. So if you want to introduce yourself, Octopus, we'd love to hear from you.
Hello, everyone. I am Octopus. I have been in crypto since about summer of 2014 and been in the TE community for about 2.5 years. I was one of the co-authors of the TE Fundamentals course, and I'm very excited to be here.
Yeah, thank you all for being here. It really means a lot. Now, I want to start our discussion today giving our audience a little context for what token engineering actually is. I feel like this is a discussion that doesn't get enough attention because we all have our own individual perspectives on what it means to be a token engineer and what the act of token engineering actually entails. And I'd like to start off this conversation with a question with you, Trent. Since I believe you were one of the first to use the term token engineering, what is token engineering, and when did you realize that this was a nascent field of investigation that needed to be developed in a similar manner to any other form of engineering?
Yeah, so maybe I'll just talk about things chronologically. I studied electrical engineering from 1994 till 1999 in Canada. And Canada, as part of that, you have to study an ethics class. And Canadians take being an engineer quite seriously. If you want to be an engineer where you're registered with the APIGS, it's this Professional Association for Canada, then you have to make an application and give information and keep paying your membership fees and so on. So there's a real community around being a sort of true professional in Canada that way. Also, and you've seen this in my blog posts, when you start, you learn that once you graduate, you get an iron ring. And the story is this iron ring was from a collapsed bridge because the engineers weren't paying enough attention. So you have to be thorough, you have to be responsible for this, etc. And so that was drilled into us, day after day, year after year in my time at the college. And we did, in fact, get the iron ring in a very special ceremony at the end. And I wore that proudly for years and years and years, and still would, except I just try to wear less rings and stuff these days. So that was sort of the philosophy of engineering, in this case, College of Engineering, University of Saskatchewan, Canada. And I gathered that it was quite similar philosophy throughout Canada. At the same time, I did a degree in computer science. That's why it was 5 years. I could get 2 degrees. In computer science, it was still part of arts and sciences, so it wasn't considered engineering. And there was actually a debate going on in the world, in the college itself, of should there be a software engineering degree? And the computer scientists were fighting with the engineers, from different departments. Should it be here or not? And if it is, who gets to run it, et cetera, right? And I remember watching these debates and heated debates between the dean of engineering, say, and different computer science professors, et cetera. In the end, interestingly, they had an interesting compromise, which was you could get a master's in software engineering that was co-run by the departments of computer science and engineering. I don't know what it is these days, and I know in other places it's purely engineering, run by engineering, et cetera, et cetera. And there really is difference, and at the heart of it, I came to realize very, very early on from those debates. In fact, I was a representative for the College of Engineering as a student to the Student Society, so I had to actually stand up and sort of defend engineering back then even. And I learned back then there was a big distinction between science and engineering. In science, the KPI is to learn, to build knowledge. That's the main KPI. In engineering, the KPI is to design, build, deploy, and maintain artifacts that work. And to take responsibility if they fail. And so it's one is about knowledge, the other is about things that are existing in the wild. And I realized that in crypto land, going back to that, as I was designing the token design for Ocean, I was looking for hooks on sort of methodologies, et cetera. And there was sort of a lot of randomly scattered ideas, no sort of broader body, no corpus of things. I had written a blog post on a stack for tokens, and there had been a couple others, give or take a year, besides me. I think Kyle Salmani had one, and I forget who else, one or two others. And that was some of the beginnings of trying to make some sense of what was going on. But any engineering field does have a corpus of knowledge as well, a corpus of building blocks. For example, in analog circuits, there's about 30 building blocks that from those 30 building blocks, everything else emerges. I did it as part of my PhD. I figured out a way to have a well-defined rule system to combine these building blocks from which 100,000 different circuit topologies could emerge. So I recognize that, and this is a common thing. If you study mechanical engineering, these building blocks are different sorts of gears and camshafts and whatever else. In circuit land, it's resistors, capacitors, transistors, and higher level things like current mirrors and op amps. And every field is like this, and this was starting to emerge in the world of tokens too. So there was basically, theory emerging, which was sort of the science side. So things from cryptoeconomics, et cetera. There was practice, people having different recipes of how to do things, different flows, et cetera. Tools, there were some basic tools emerging, manual, some very basic software. And also people saying, we need to have the ethics infused. And a lot of the leading protocols were publishing, when they were, doing their ICO or before, they were writing a mission and vision statement, blog post, whatever. And that's in line with, a lot of leading companies before that too. And sort of as part of all this too, this body of knowledge, this corpus, all of this, right? So there's this collection of stuff, and it was scattered throughout. But really, I realized I actually started to write the super long blog post that was like, I don't know, 20 pages long. And as I was writing it, I was really trying to wrestle it down into something that made sense. And I didn't have the word token engineering there. And then I said, I realized it was more of an engineering discipline. So I looked at a bunch of different options. Should call it token engineering or a bunch of other ideas. And finally, that blog post I broke into 3 blog posts. That's the TE1, 2, 3 blog posts that I wrote. And in the second blog post was when I introduced the term. And around that time was when Zargham was also considering this. So I met him around this time too, and we met in New York for the first time, and immediately got along super well, and we've got along very well ever since too. And he'd been considering ideas, and we agreed, yeah, it makes sense to just settle on agreed upon a term and run with that, even though there's lots of possible terms out there, as sort of the Schelling point for a whole field to coalesce around. And talking with Zargham, he's a control systems engineer, so he had some leanings to things related to that, like crypto economic systems, et cetera. They all make sense. Myself, I saw, with electrical engineering, you've got electrons flowing around, so it's about the thing that flows around. Mechanical engineering, the artifact is these mechanics. Engineering physics, same thing. And a short name helps. So those were some of the considerations, and we ended up with, saying, let's go for token engineering, knowing that there's lots of other labels, lots of other fields that feed into it. But once you have the label engineering, it means a very specific thing, right? It is this theory, practice, tools, and ethics towards designing, building, and shipping and maintaining tokenized ecosystems. That's, I think, a definition similar to what I published many years ago now. And it's the one that you'll find reverberations of that everywhere. And it's sort of, what Zargham and I agreed upon, but also with discussions with Angela and all the other people in the community at that time. So that's, and basically it's stuck, right? It's short, it's easy to say. It's sort of riffs with token economics, which is a science, right? Token economics, it's a subset of economics in a sense, but it brings in the token side. That feeds in. Or token economics / tokenomics is the shortened version. And lots of other sciences too, as Angela mentioned earlier this call. That's a bit of the summary of where this came from. And but I think that foundation of the why makes as much sense as ever, right? And there's lots of other professional societies too that I should mention, right? As an electrical engineer, there's the IEEE, the Institute of Electrical and Electronics Engineers. Same thing for many, many other professions in engineering. So unlike almost every other profession, you actually have to build and ship systems that people, trust their lives on, right? If you're a scientist, you just put out knowledge. I shouldn't say just. There's amazing stuff, and I love science, and I have many awesome scientist friends, and I consider myself, an armchair scientist sometimes. But anyway, as an engineer, though, you have to build and ship these systems, and that's where the responsibility comes in. So the other stuff, engineering helps to coalesce that together, but sort of the final nail in the coffin, the essential nail in the coffin is the ethics side, the responsibility for whatever you build and deploy. I'll stop there.
Yeah, no, thank you. That's really awesome. And ever since you mentioned that term, token engineering, the development of the field and of this area of investigation has really blossomed. And so this kind of leads into our first collective topic, which is on the importance of token engineering today. And I was hoping that maybe each of you of the speakers might have your own thoughts on why you think token engineering is important and what excites you most about its development. And so maybe we can start with you, YGG, and we can pass that around.
Sure. Thanks, Nate. Yeah, just maybe set some context of the world that we're landing in here. We're in a globalized world. If you look at the development of air travel over the last 80 years and the development of the internet and the connectedness that we've all landed into here in 2023, we are operating in a globalized digital world. And what we have with token engineering is the ability to engineer the value flow systems throughout that hyper-connected global digital world. And I think there's a lot of power and responsibility that comes with that. I mean, if you just look at the story of crypto, it would make for the best Hollywood movie ever, right? The ups and downs, the booms and busts, the scams and the failures and the hacks and all of this. There's a lot going on, and with engineering practices, we can essentially do better. We can apply engineering so that we have an understanding of what we're designing, what we're building, what we're putting out into the world. And like Trent says, the maintenance, which is not very embedded into the culture of crypto. There's a lot of like ship it and move on to the next thing kind of mindsets. And so I think by anchoring the field, and I would say even centering the field around token engineering, we can set ourselves up for success as honestly as a globalized civilization. I think this is the next step. We have to think about the value flows, what they mean, think about the ethics around them, and how we can apply engineering to get the results that we're collectively aiming for. So I think I'll kind of set the context there, and maybe I'll pass it over to Octopus if I can do that.
Thanks, YGG. I'm excited about token engineering for the fact that it can help people make responsible decisions and also provide a common language for discussion about the systems that are being implemented. I will pass it to Livia, if you're up.
Thanks, Octopus. Yeah, I think something that came up a lot in the study around what is token engineering and what is important about token engineering, I think, is this idea of building public infrastructure and how responsible the building of this public infrastructure should be, like Trent just said it so clearly. And I feel like also the understanding that we can create complex systems. Like before, I don't think there was this awareness or even the possibility of creating complex systems, like creating economies, having the possibility to think economies beyond nation states, and what does that represent for our society? How can we play as responsible agents inside the system? So yeah, I think token engineering is important to bring this, bring more awareness about how systems function, what is our role in them, and how to build better economies and better social economies from that route. And also something interesting on the use of tokens instead of like tokenomics design, like why token engineering instead of token economics. I think also because engineering can be beyond economics, like a reputation system, for example, that uses tokens might not be purely economic. Or maybe there are examples from economic design that we want to change, or there are things that are so rooted in the think of economics that if we think beyond economics from this idea of value transfers and how they can be safe and also maintain some type of privacy. And I'll pass to you, Angela.
Let's forward it over to Trent. I know Angela's currently working on some technical issues with the speaking part of it. So Trent, do you have any other things that you're excited about in regards to token engineering development?
Yeah, lots of things. I think, but I'll be short. Overall, right, I see that we are building civilization level infrastructure, as YGG pointed out so eloquently. And think about it like this. If you are going to go build a new dam, maybe something at the scale of Three Gorges Dam, are you going to hire an engineering firm with, say, 10, 20, 30 engineers with decades or hundreds of years of accumulated experience? Or are you going to hire, a few random people who, raise their hand and say, hey, I can help, I have some ideas, right? Who have no training or experience and sense of responsibility, right? If you want things to be built to last, then you need an engineering mindset. There's exceptions, but this is almost always the case. Sometimes people have engineering mindsets without being officially trained as engineers. That's completely fine, right? The Wright brothers, for example, they had an engineering mindset, but they weren't officially engineers by degree. So token engineering explicitly, pulls the crypto field saying, hey, there's this idea called engineering, and it has this super strong sense of responsibility, and everything around it, the patterns around it, the tools and the theory to do things, leveraging crypto economics, leveraging practice, leveraging corpuses, but all with this deep, deep, deep sense of responsibility for building civilization infrastructure for the long term. That's what really matters. Usually public goods, but it doesn't have to be public goods too, right? There's a lot of things that are sort of pseudo-public, pseudo-private, or fully private, and those can be engineered well too, right? I just drove a Volkswagen car just before this call. It's a private company, right? It's not a public good per se, but they have engineers designing those cars because, well, economically, if those cars crash too much and kill their drivers or passengers, then they'll go broke. But also, if you're an engineer and you ship those cars, there's regulations where people have to be engineers to even design and validate and verify those cars, right? So society beyond engineers, society, governments, et cetera, do have regulations around engineering, and that's actually a really useful tool to help ensure, safety and rails for civilization as we go forward. So to summarize, we're building civilization level infrastructure and deploying and maintaining it, and therefore engineering is the best mindset, framework, discipline in which to build and deploy this. Thank you.
No, thank you. Yeah, and so our next topic that is kind of about understanding who token engineers are and what it takes to become one. I wanted to ask Livia a question to start us off here, because you have been overseeing the token engineering stakeholder study that has reached out to known token engineers in order to get a better perspective on the challenges they face and what it takes for them to be successful. What have you learned with this stakeholder study, and what are some insights that you think are important to discuss?
Yeah, it's really so many insights. We have 128 pages document now that we're looking at with a lot of the amazing quotes from participants. But the biggest thing for me was the need for standardization. So what is the challenge to get to standards right now? It's because there is not benchmark. It's really hard to see what projects were successful or not. Like, there's not much academic literature on common patterns and results. Like, what happens after tokens are launched? How are the systems behaving? How can we have better analysis to validate the best practices? We can't just only focus on tokens and ignore what happens. Like, what happens when you launch a token? What is, I think there's something after the deployment, that the deployment is the process where humans are inserted into the mix, and that can really change everything. So I feel like having just better analysis after that process is really important. And building a library of models, that's something a lot of participants alluded to, the lack of, you don't see many models one next to the other to be able to make better choices about the new models you're building. And I think there was also something around liability, like who is liable for a complex system when there are so many parts that are making the whole. So would a token engineer be this person that overlooks the whole system, or is token engineering only referring to a team of people? Is there one single token engineer? And if there is, would they be liable for the whole system? And what are some standards and maybe certifications that can be there for, like right now, if somebody builds a bridge, this person is probably accredited engineer. But somebody that builds an economy are they accredited token engineer? So I think, things around also creating demand within the crypto community for token engineering audits. That's also a concept that came up. How could a token engineering audit be exemplified? Like how could it be structured? And how can we increase this demand for people to understand that a token engineering audit is very important, that you can't just keep putting tokens out there and putting the systems out there and not looking at how they function. And I think this also tied to regulations and the legal aspect of how standards could help legality become an easier bottleneck. Because if regulators understand that the field have standards, there is a common language to communicate with. But I'll stop here.
No, and that's the study is pretty phenomenal, and it's very ambitious what you've taken on to reach out to these token engineers and to really understand what they're going through. And so, I think this is a good lead into our collective discussion on this topic is what are the best ways to become a token engineer, and what skills do you think are the most useful? And I'll send this over to you, Octopus, because I think you probably have some good insight into this question.
So I definitely, my training as a mathematician, but I really think that the most important part of mathematical thinking is not in the specific products of the thought, but in the process of thinking through things. So I definitely feel that having a background with the way that different information can flow, whether that's through filters and signals or other perspectives, circuits, graph theory, lots of perspectives are helpful for that. But I think the most important thing is the ability to think critically and creatively about that you're not just going to plug and play these designs, but you're going to actually engage with thinking through the system and thinking through the potential scenarios. Like the hardest part of testing is thinking of the edge cases and the attacks. So I think that those two skills together, both the sort of more fundamental, lower cognitive level, which is not an insult, it's just the descriptor that describes it, of like equations and update rules and things like that, but also the higher level overview of what can go wrong with those things and really understanding the modeling process in all of its forms.
Yeah, and I think this is a really important topic to discuss, because I think there are a lot of potential token engineers out there, and they kind of question, like, what skills do I need to think about, and what skills are most useful? And I kind of want to keep this conversation going. If Angela, do you have any insights on this, especially being around the education around token engineering?
Yeah. Can you hear me well? First, let's check this.
Oh, yeah, we can hear you.
Okay. Yeah, glad. All right. I mean, at the Academy, of course, we are, first of all, training T fundamentals as being a program that introduces the total token engineering process. And this starts with the discovery, system purpose and goals, the stakeholders and their motivations, value flows between these stakeholders, causalities, feedback loops, and then start with the mechanism design. Then you go to the design, translate these findings from the discovery to a mathematical language, defining action space, variables, system state, also performance indicators. So what makes our system successful? What are indicators? Is it just number of users? Do we have better indicators? Then the deployment in our case means this modeling and simulations, understand how our system might break, when our system might break, stress test it, find the best parameter setting, usually in Python, and then governance, also decentralization, DAOs, algorithms as policy, computer-aided governance, voting systems. So this is what we teach at TE Fundamentals. Now, what we also know is that this is a lot, and it tries to introduce the general token engineering process. However, the space has we are seeing subdomains emerging, like crypto economics, where you have a focus on mechanism design and cryptography. Then supply-side tokenomics and demand-side tokenomics that are much more focused on how can I get users on board, how understanding the stakeholders, product market fit, understanding like how can I grow my active user base, drawing a lot from Web 2. Then quantitative incentive optimization, or another super relevant field, risk management and token engineering verification. So just mentioning some of the subfields we are seeing emerging where you can, with a certain background, start diving deeper and find out how to provide value to the overall process. Because in fact, when it comes to supply-side tokenomics, token sales, setting up a token sale, understanding the long-term effects of defining supply matters, mechanism design, you should have a strong understanding of economics overall and game theory and how to model these systems. Risk management, there's so much to explore from a data science perspective and stress testing perspective. And it's usually hard as an individual to cover everything. And instead, we recommend our students to define their own personal curriculum that matches to their prior knowledge and prior experience, and explore these subdomains to better understand how they can get active, how they can apply existing skills to the token engineering domain, and also how to start working on projects. Because I think theoretical learning is nice. Start building, start exploring, start adding value to this overall ecosystem, and finally become a token engineering practitioner is most exciting.
Yeah, does anybody else have any thoughts as well in terms of the useful skills or things that you find important in terms of being a practitioner within this space as a token engineer?
I have a quick answer, sort of to the original question, what makes a token engineer? To me, a token engineer is someone who can design, verify, build, deploy, maintain, and evolve a crypto economic system. It can be small, it can be large, but if they can single-handedly do that on their own, then that counts for a lot now. But it has to be guided by and influenced by the theory, practice, tools, and sense of responsibility of token engineering. And you have to have an ability to not just press a button 1, press button 2, but have insight, have skills to verify things properly, et cetera, right? So how do you do each of these things well, thoughtfully? But at the end of the day, it is about building, deploying, and maintaining, right? To summarize. There's a few, the previous speakers talked about verification. I'm one of the strongest advocates of that, so fully agree. But it's all of this. So if you're an engineer, you graduate somehow from university where you've never designed anything and it's all theory, you're going to have a hell of a time being effective. But if you're an engineer where the curriculum has included design classes, ideally year 1, year 2, year 3, year 4, where you're actually doing design, you're doing labs, you're doing a bunch of hands-on stuff. Ideally, you've had some internships. Ideally, you've had some engineering-related summer jobs. All of those are the things that really matter. They tie to the theory, but it's really, really important that the theory doesn't dominate and is the 99.9%. Theory should be, you know, the 25 to 50%. Practice really matters. So, and one final, yeah, I'll stop there. So ultimately, you're only a token engineer if you can actually design, build, deploy, and maintain these tokenized ecosystems with reference to the theory, practice, tools, and responsibility of token engineering.
So right now I want to take a pause before we get back to our last two topic discussions and invite anyone from the audience if they have any questions for our panelists. If you have a question, please do hit the request to speak button. We would love to hear from you and answer any questions you may have. Give it a second. All right. Well, let's go ahead and move into our fourth collective discussion topic, the future of token engineering. I wanted to start this discussion off with a question for Octopus. There are no doubt a lot of exciting potential developments within the field of token engineering, but I wanted to ask you if there was anything you think is missing from the current landscape of token engineering, or something you would add or change to make it better. Yeah, I'll send it to you.
Well, one thing I appreciate about the introductory essays on token engineering is how they point to reflection on what has gone wrong in a process. And I think that probably from my experience, it would be helpful to have more adversarial thinking, front side reflection on the back side when things don't work as we expect. So we in the token engineering community have had a chance now to deploy some mechanisms and some systems, and now we can reflect on, did we understand what we were doing? Why did they work or not work? What could we improve, not only about the process, about the decision-making process that led us to choose those? So I think optimism and belief are great, but I think that rigor includes questioning and even attacking things. I was rereading The Pragmatic Programmer recently, and it suggested that every software project should have a designated project saboteur. And I think that, you know, red team is underappreciated. Team in one way or another. It's just a matter of how much you pay them and when.
Yeah, and let's dive into this discussion topic, which is where the field of token engineering is headed, and what areas excite you the most, and maybe Trent, you have some insight into this. You're very, very forward thinking, so I really appreciate to hear your thoughts.
Sure. Well, I mean, even in the original essays, I talked about token engineering becoming an engineering field standing side by side with electrical engineering, mechanical engineering, you know, the new entrant of software engineering, et cetera, right? We watched software engineering become an engineering field from the late 90s throughout the 2000s. Now there's no question, right? And sometimes there's mergings, right? Sometimes it's computer and software engineering, or computer engineering is different than electrical engineering. So, or sometimes it's just purely electrical engineering, right? So overall, you know, I'd love to see 20 years where token engineering is side by side with the other disciplines. You go to any university, whether it's University of Saskatchewan or Stanford, and they've got a token engineering department, right? But I see that, you know, traditional academia, I expect that it will embrace it, and traditional academia isn't going anywhere. But I also hope that token engineering itself can establish its own accreditation system for what it means to be a token engineer by its own flow. And this is actually what's happening with Token Engineering Academy, et cetera. And I think that's awesome. So 20 years from now, there will be token engineering taught in the universities, but there will also be this, ideally one, maybe several really awesome institutions that accredit on their own as these public goods that people, respect at least as much as a Stanford degree, if not more, right? I think that'd be wonderful. So that's where, and we can leverage the tools of blockchains and token engineering, et cetera, which is a really cool opportunity, right? All the governance stuff, et cetera. Along the way, we have a long ways to go, right? We're 5 years in. So, that would be, chronologically, that's 20% there. And that feels about right? In the sense of, we've went from 0 to thousands of people who have studied token engineering to some degree, use it. That's amazing, right? But we have a long ways to go, right? Professionally, I think there's about 10,000 people who consider themselves professional analog engineers, and probably about 100,000 people who consider themselves digital circuit engineers, analog circuit engineers, digital. So not that many. Maybe other stats might say 1 million, but it's not huge, right? So I think it'd be awesome if there was 100,000 plus people who consider themselves professional token engineers with, with whatever accreditation there was at the time that met that, right? With subfields too, just like, in electrical engineering, there's analog, there's digital. You can even dive deeper, more subfields like memory and more. So that's along the way, from where we are the next 2, 3, 4 years. So the very far is easier to predict, and the next year or two is easier to predict. It's the medium term that's wobbly, right? In the next 2, 3, 4 years, I'd love to see much more emphasis on verification. Right now, design is fun. Anyone can do design, but as many of you have pointed out, verification is really important, really needed. And we've been a bit sloppy on it because I think it's you have to be more disciplined to approach it, right? My first startup was doing AI for design. My second startup was doing AI for verification. I wouldn't have felt comfortable doing AI for design in my first startup. I didn't have the experience. I didn't understand things well enough. But by the time I got to my second startup, I'm like, yeah, game on. Because there's core questions when you're doing verification. If the verification tool says, yes, verified, how can you trust it? That is the essential question. Repeat that. How can you trust it? And it's not easy to figure that out. Yes, you could have a mathematical proof. That works in some cases. But if the state space explodes such that you have no chance in hitting this, then what, right? So we need to get way better at verification. We already have this, some digital verification. This is what we have with smart contract audits already with things like Slither. We have fuzz testing and other stuff. But we have almost nothing for analog circuit verification. Sorry, analog token verification, the analog side, right? This is why we have hacks and bridges. This is why we have DeFi hacks where people do flash loans, all that. If we had good analog token verification tools, a lot of this would go away. And we also need better system level verification where it's combining the digital and the analog. So if we have verification where it's really thorough digital, really thorough analog, and then merging these on higher and higher level, mixed signal token verification, we would come a long way. The thing is, this isn't easy. It takes responsibility. It takes hard work. We can't just play around, right? And so fortunately, we do have recipes for this. I came from that exact field for analog circuit verification. I've written and talked about this. I think that can make a big difference in the next 2, 3, 4 years. And I really hope that a token CAD industry will emerge. We're starting to see it, right? There's people doing services for this, the block sciences of the world, the gauntlets of the world, some with internal tools. There's actually a lot more internal tools than many of you realize. A lot of teams have built their own simulator before they shipped, right? And that's the baseline, right? CAD and TokenSpice as sort of the simulators for this. But then we need to build tools on top and tools on top of that and tools around to help design, et cetera. So that's what I'm most excited about as the key missing thing right now in token engineering is really going for cracking this problem of token engineering verification. Digital, we've done a bit, but the analog token verification and mixed signal token verification, the tools around it, and making that part of the standard flows that we have in token engineering. That's what I'm most excited about, and I think is most important for the next 2 years, 3 years, 4 years. Thanks.
Yeah, and I'll extend this question to Angela and YGG, Livia. If you guys have anything that excites you about the future of token engineering or insights of where it's heading, please do speak on that.
Yeah, I'm also excited about the tools to come or methods for verification and improving the robustness of our systems. I think here's a lot to gain from other fields beyond crypto, and also we have a big chance to prove that crypto is can be robust, can be reliable, and crypto can be a step towards solving really important challenges in our economic systems. And I'm really, I hope we can make token engineering as relevant as it needs to be. I think there is still a lot of work to be done. I think the space is very dynamic. Not everybody calls it token engineering. Nevertheless, it's really relevant for achieving the goals you all mentioned in the past 30 minutes. So I guess we play a really critical role in the success of crypto. And we should keep our eyes peeled, also see how to develop public goods in this sector to make it, to make people pay attention and give the token engineers the role they deserve in the design and in building and continuously developing these new economic systems.
Yeah, YGG, Livia.
Thanks, guys. Really, really fascinating discussions being shared. I want to share quickly a kind of complementary concept that people can think about. I really enjoyed Trent sharing about mixed signal verification. That's really exciting. There's something special about the tech stack that we're all operating on when we think about blockchain. The artifact of the blockchain is this public database that, in theory, will never go away. We have all of eternity to do post-deployment analysis, which has been called out a few times in these discussions. But everything we do, when we're talking about Ethereum or Bitcoin, every transaction that we make is forever recorded on chain. Every time you interact with a DAO governance system on chain, when you buy an NFT, when you interact with some DeFi platform, every time you touch the chain, that is recorded. And we can do, this is really exciting from a data science perspective, because this is really new. I don't think we've ever quite had a global substrate like this that is recording. It's like so I want to quote Simon Delarouvier from the recent TE stakeholder study. He said what he's most excited about in this space is blockchain moving from financial first utility towards provenance first utility. He believes that the fact that every interaction with the chain is recorded is actually going to surpass the utility of blockchains relative to what we've seen so far, really being the financial utility of blockchains as the primary attractor. But I'm really excited about this idea of provenance first utility of blockchains. All this data is recorded, and it's open to the public. We can go look at it. We can see how these things are doing. And it's really to the token engineering space. It's a call for post-deployment analysis. This was called out by a few people, Livia, Octopus on here. But we need to think about what we've done, what went right, what went wrong, what metrics are we observing, what do we want to optimize for. We have a special privilege of being able to access the chain. And really quickly, one other thing I wanted to shout out that is really exciting for the future of the space. There's been over 3,000 students that have passed through the Token Engineering Academy. And to think of that from a human capital perspective, 3,000 people over the last 3-4 years who are attracted to this space and want to learn and want to contribute. I think there's a huge opportunity for leadership across the space. And I think there's a need for apprenticeships and also discovery and standards for projects. I know as a token engineering firm with Longtail Financial and talking with Block Science, there is a huge amount of resources that go into project discovery and scoping, budgeting, timelines, addressing what a project really needs from token engineering. And I think this might be a role that the TEC can fill, or there might be a space for a firm to emerge that specifically offers project discovery, scoping, and the development of standards. If we can start to standardize the tooling and the processes that projects are needing from token engineering, I think there's a huge opportunity with that. And I've just got a little list in front of me, so I'll say the last thing I had here, which is partnerships, industry partnerships. There's DAOs out there with billion-dollar treasuries, and we need advocacy for token engineering to work across the industry, both crypto, DeFi, also traditional. Token engineering can be applied in a lot of traditional settings, and then of course building partnerships with universities. And the work of Chris Peruk on this has been really phenomenal with what he's been doing. Yeah, I'll stop there.
Yeah, thank you. And before we wrap up, I want to shout out to Ben West from Gitcoin, who has been a big supporter of the Token Engineering Commons and our current grant round. I don't know if you have any thoughts on the discussion here of token engineering, but love to give you a moment to give us your thoughts.
Sure, absolutely. Thanks for having me. And first of all, I just love to say how exciting it is to listen to this conversation. As somebody who had an interest in local currencies and sort of alternative economic models, long before getting involved in the crypto space, it's just so refreshing to hear a conversation that is, so thoughtful and not entirely focused on like monkey JPEGs or something like that. In particular, I'll say one thing about sort of non-monetary uses of blockchain technology, taking off my Gitcoin hat for a second. I'm doing some research right now for the Ethereum Foundation, funded through grants that they put out on blockchain-enabled climate solutions. And we're looking a lot at things like local energy grids, supply chain management. There's a lot of non-monetary use cases that are floating around out there that I think are totally fascinating. And honestly, even just, the basic use of, creating new tokens to fund projects has been a real game changer for a lot of important projects. And, I think the more that we can sort of turn those tokenomic structures into something that's ongoing and sustainable, I think the impact that's possible is really huge. But I think I'm primarily here just to give a shout out to the Token Engineering Commons grants round, which is happening right now. Very thrilled that is one of the featured rounds in our ongoing grants round that just started today. GG18 is being called, the 18th quarterly grants round that's being run by Gitcoin. Shout out to Octopus, by the way, for all the work that you did helping with fraud detection and defense at Gitcoin over the years. Big fan of the contributions that you've made, sir. Thank you for all the work that you've done. But yeah, basically, I'm just here to say go check out the grants round for anybody who hasn't. I'm sure pretty much everybody here is very aware of it, or probably is a grantee. But if you go to grants.gitcoin.co, you can see all the details of the various rounds there and click your way through. I'm happy to answer any questions or just be of service in whatever way I can to the conversation here today.
Yeah, thank you, Ben. And I want to thank all of our panelists for showing up and discussing token engineering. You guys are true pioneers in this space, and we're all very, very grateful for the work that you've put forward. But before we wrap up, I want to hand this over to Gideon, who is a big part of the Token Engineering Commons team, and he's got some information about the grant round for anybody who is interested for the projects that are participating. And so, thank you. I'll pass it to you, Gideon.
Thanks, Nate. Wow, what a great conversation. So yeah, I'm just I want to build on what Ben just said. We've got our round opened up today, and the easiest way to get to it is just go to the TEC's Twitter page, X page. It's TECM as in Mary, N as in Nancy, S, and pinned at the top, there's a link, so you can just jump right to that. And while you're there, if you're not following us, please do so. This is a great conversation. We plan to continue this on into the future. This round, it's on Optimus. So these are just like a few kind of technical things. This is, we're doing this round on Optimism. You can pay. You could when you make a grant, when you contribute, you can contribute in DAI or ETH. We've got right now just 14 projects, so it's this is a pretty focused round. We were very careful and just trying to keep the grants really focused on three things: token engineering research, token engineering education, and token engineering tooling. We've got a $25K match from the TEC. And one of the interesting things about that is just that we've been doing some kind of cool experiments with fusing Gitcoin's quadratic funding approach with subject matter expertise. So basically kind of boosting that match where we detect that the donors have some level of token engineering expertise. And if you're interested in that, there's a Medium post that we did on the token engineering Commons Medium page if you want to find that. We'll be on Thursday, so just a couple last things before we round up. Before we close this space. One is that on Thursday we're going to have another Twitter space. We're calling it a fast pitch Twitter space, where we're going to be inviting some of the grantees on, and they'll just be doing quick pitches for their grant. That'll be on this Thursday at 1 p.m. Eastern Standard Time, 5 p.m. UTC. And then we're going to be doing we have another opportunity to hear from the grantees. It's going to be on next Tuesday. That'll be also the same time, 1 p.m. Eastern Standard and 5 p.m. UTC. And this will be hosted. This will be one of the Gitcoin Shill spaces. Just before we close, I just want to say, this, when you go into this round and you look at the grants that we've put up for you to fund, you're not going to find solutions to the climate crisis or world hunger or anything like that. It's not a round that's really focused on supporting that kind of good, at least directly, right? Those public goods, what we're focusing on is lower down in the stack. It's like the infrastructure that supports those kinds of cool applications of blockchain technology. And it's even one layer below that. We're supporting a new engineering field that makes sure that we can have that infrastructure and that it's safe and reliable and that it actually does what it says it does. So this is kind of a little bit more discerning, longer term bet, and we hope that you'll join us in making that bet with us together. So with that, I want to thank our speakers once again. What a great conversation. And I want to thank everybody for joining us today. Great call.
Yeah, thank you, everybody. It's been amazing.
Thanks, everyone.
Thanks, Nate, for hosting. Thanks, everyone.
Thank you all.